What is LIFO? Last in, first out. Here, the last element inserted will be removed first. That is the meaning of last in, first out. If you want to remove the element from the stack, we have to remove only the first element. Pop operation is nothing but removal of data item from the stack at the pointer top. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today let us start our session with a concept, stack. Now, let us see what is a stack. Stack is an ordered collection of data items where addition of new items and removal of existing items always take place at the same end. This end is commonly referred to as the top. The end opposite to top is known as the base. So this is the definition of a stack. A stack is an ordered collection of elements or items, and here addition and removal of existing items or data items takes place at the same point called as the top. So that is the top is the place where the addition and removal of element takes place. Then it follows the ordering principle is sometimes called as LIFO, that is last in, first out. This is one of the principle followed in stack. What is LIFO? Last in, first out. Here the last element inserted will be removed first. That is the meaning of last in, first out. Newer item are the near the top while the older item are at the base. Here as we start adding new elements into this stack here, so the top is the pointer, it keeps increasing, and the opposite to top is the base where the older elements are near the base. And example is stack of books on a desk. So this is an example of a stack. Student, what is the meaning of a stack? It's a data structure. So if a data structure, you know what is a data structure. Here the elements are arranged in a definite order. It is a linear data structure. And here example for this is stack. It is one of the data structure. And here remember the points. Top is the place or it's a pointer where insertion and deletion takes place at the same point. And example is stack of books on a desk. For example, for this, suppose if you on a table or on a desk, if you keep stacking a books, keep books one over the another, so it forms a stack. That is an example for a stack. In that example, at the beginning on the table, there were no books. So we can say stack is empty. There are no books on the table. So when you start inserting or keeping one book on the table, then it is we are adding one element to the stack. And if we keep one more book over it, it is we are adding second element. So this is how the stack grows. So this is an example for a stack. Now let us look on to next slide. Stack can be represented using a one-dimensional array. Now in this example, we are going to study how we are implementing stack using one-dimensional array. You know what is an array is. So here, the items into the stack are stored in a sequential order from the first location of the memory block. And you know this in an array, the first index is 0 and next index is 1, so on. So in the same order, the elements are added into the stack because we are implementing stack through an array. Now a pointer is top. This is the top is the pointer. It contains the location of the top element of the stack. So top is the pointer. That is the place where we are inserting or we are adding new element to the stack. A variable is a max stack contains the maximum number of elements that can be stored in the stack. So this is nothing but length of your array. So maximum stack, once the stack is full, the condition is called maximum stack. So it indicates that maximum number of elements that can be stored in the stack. and the condition top equal to max stock indicates that the stack is full, and top equal to null indicates that stack is empty. Now, let me explain this concept through this diagram. Now, as we are implementing stack through array. Now, you know what is an array. It is a group of elements of same data type. In this example, index 0, 1, 2, 3, 4, 5, it goes on like this. And here in the stack, top is the pointer. So here in the beginning, look at this example. As we are considering, there are 3. The size of the stack is 3, where we can insert only 3 data items. At the beginning, stack is empty. That's the meaning is stack is empty. And here, when as and when you insert one element to it, so the data item 1 is inserted into stack. So, and next element will be inserted on top of it. So it goes to the next position. So similarly, if you want to insert one more element, it will come to this position. In this example, now in our previous slide, we have learned few technical terms, like one is top. What is the top? Top is the pointer variable where the insertion deletion takes place at this pointer top. Look at this example. In an array, the index is 0. First element is 0. So here, if we implement a stock on an array, so this will be the first element. Suppose this is the place where we have to insert new data. In this example, we say top equals to -1. When top equal to -1 here, what is the meaning of that? The stack is empty. The word is stack is empty means there are no elements in the stack. So top equal to -1. Next, if we want to insert one element in the example 1, for example, this is empty stack and this is the place where we have to insert new element, that is the pointer top. So here at the beginning, top is -1, it indicates it is an empty stack. There are no elements. Suppose if you want to insert one element to it, so here the top pointer should come to this point. So this is index is 0. How do we get index 0? Here top equals top plus 1. So we have incremented the pointer top. So accordingly, now what is the value of top? You have -1 plus 1, that is equal to 0. The value or the pointer top points to index 0. This is the place where we can insert new data item into this stack here. So now at this stage, value of the top equal to 0. At the top point equal to 0, we are inserting one element. Now, if you want to insert one more element to this, though this top pointer should come to this location. Here in the index, in an array, this is the index 0, 1 and 2. So here at the beginning, index of this array or this point is 0, we have inserted one element to it. Now we want to insert one more element into the stack. We have to move this top pointer from here to this point, that is top equals to top plus 1. Again, if you say top equals to top plus 1, that is 0 plus 1, that is equals 1. So now this is the place where we can insert second element. So this is how we say the stack is growing. Same example is here. When this is the point where you have to insert second element at the index 1. Suppose if you want to insert one more element to int, for example 3. If you want to insert here, the top should come to this point. So here is index 2. How do we get index? Top equal to top plus 1. So at the beginning, top equal to -1, it's an empty stack. And we have to keep on increment the value of the top pointer by +1. So then that is the place where we can insert new data item. So that is why we say stack is growing in this direction. That is the meaning of the stack is growing. Next one is, in this example, we can insert one more element to it. For example, 3. So here index is this 0, 1 and this index is 2. This is now there the size at the beginning, the size of a stack or array is 3. We could insert only 3 elements. Now we have inserted 3 elements. Now, if you want to remove the element from the stack, we have to remove only the first element. In this example, 3 is the last element inserted, that has to be deleted first or that has to be removed first. That is the meaning of the concept LIFO, last in, first out. So in this example, 3 is the number or the data item we have inserted last, that has to be removed first. So that is the meaning of LIFO. This is the stack is a data structure which follows LIFO principle, and every time the top is a pointer which keeps incrementing by +1. In this example, at this stage, the value of top equals to 2. We can say stack is full. This is the condition. Stack is full. In this example, there are 3 data items. We can say, for example, n is the size of the array or the stack. This is 1, 2, 3. In this example, we can insert only 3 data items. Size equals 3. So what is the last index of this here? Last index is 2. So that is n minus 1 equal to 2. This is the last element. So the top is at the index 2. Now the condition in that example, if I say top, if top is equals to n minus 1. Please understand the concept here. At the beginning, top, it was -1. As and when the stock is growing, it reaches to the maximum element. That is, in this example, index is 2. That is n minus 1. So if top equals to -1, then we can say stack is full. In this example, size is 3. So we have reached the maximum element. We have inserted the maximum elements, 3 elements. Now the stack is full. What is the condition here? Top equal to -1. The condition indicates that the stack is full. Now we cannot insert new item into the stack. Now if you want to remove the element here, only we have to remove the last element inserted. That is last in, first out. In this example, 3 is the element we have inserted last, so that has to be removed first or it has to be deleted first. That is the concept of LIFO. The principle is followed in stack. Now let us move on to next slide. Now let us say what are the operations that can be performed on stack. So here first operation called stack is the function. It creates a new stack, that is empty. So stack is a function. It creates new empty stack. Next one is push the bracket item. So it adds a new data item to the top of the stack, because always insertion takes place at the pointer top. So push item means it is an operation where you used to add new item into a stack at the pointer top. Pop is an operation. It used to remove the top item from the stack or to delete an element from the stack, to remove the element. So deletion or removing element takes place at the same point top. So this is called a pop operation. Next one is peek operation. It returns the top item from the stack but does not remove it. It needs no parameters. Stack is not modified. And peek is a function or is an operation. It returns the last element of a stack. Next is empty. It tests whether the stack is empty. Next size. It returns the number of items on the stack, or it gives, in another words, we can say it gives the length of an array or the number of elements in the stack. So these are the different operations can be performed on stack. Now let us move on to next slide. Here it explains algorithm for push operation. So now let us see what is the algorithm for push operation. What is push operation? It is adding new data item into a stack here. And remember that insertion and deletion takes place at the pointer top. Now, stack is an array that contains n elements, and top is a pointer to the top elements of an array. Item is the element to be inserted. This procedure inserts item into the stack. So this algorithm is inserts one element into stack. In this example, stack is name of an array. It can size n elements, or size of a stack or size of an array is n, and this top is the pointer where insertion and deletion takes place. And here item is the new element, a data item to be inserted into the stack. Here, before we start inserting it, what is the step 1 here? Here, step 1 equal to if top equal to n minus 1, then it is stack is full, as we have seen in our previous example. So here top is a pointer n minus 1. Here n is the size of an array and n minus 1 is the last index. So if top is at the last index, then it means that stack is full and we cannot insert any more new element into stack. So we have to exit from this algorithm. So this is the first condition. Next, step 2 is top equals to top plus 1. See, because top is a pointer where we have to insert new data item. As we have seen in the previous example, at the beginning, the top pointer will be equals to minus 1. It indicates stack is empty. So if we want to insert data item, we have to move the pointer from minus 1 to 0, because 0 is the first index of an array. So in this example, top equal to top plus 1. Here we are moving the top pointer from minus 1 to 0. So top equal to 0, that is the first element. So once if you move the pointer, next we have to insert stack of top equals to item. So in this example, at the beginning, top equal to 0, stack is name of an array. So stack of 0 equal to item. Item is the element to be inserted. First element is inserted at the pointer top. So because it is in a loop, it keeps on adding element as long as the condition is true, or is once it keeps adding the elements till it reaches the maximum or n minus 1 condition. So this is an algorithm to insert new data item into stack. Now let us move on to next slide. And here another operation, that is pop operation. What is pop operation? Pop operation is nothing but removal of data item from the stack at the pointer top. So because in the stack, top is a pointer where insertion and deletion takes place at the same point. So in this example, same, stack is an array, name of an array which contains n items or n elements. Top is the pointer from where the element has to be removed. Now look at the algorithm. Step 1 is, again we have to check for the condition. If top equal to null, then print stack is empty. So here in the previous example, we have checked for the condition whether stack is full or not. But in this example, we have to check whether the stack is empty. Once if there is an empty stack, means there are no elements, data items. So it is not possible, or we cannot remove any data item from the stack. So we have to check for the condition top equals to null. If top equal to null means stack is empty, we have to come out of this algorithm because there are no elements to be removed from the stack. Next one is the item to be removed always at the top position. So stack of top, at the beginning, the top will be at the minus 1 condition, means n is the number of items. So n minus 1 is the last element. N minus 1 is the last element or the last index. So stack of n minus 1. So that is the element to be removed. What the item equals to stack of n minus 1. Now we are going to copy the element. Next, we have to move the pointer from top to top minus 1. The meaning here is, look at the example here. Suppose, as we have seen the example, this is a stack and here index 0, 1, 2. And this is the top pointer and this is top equals n minus 1. Condition where we can say stack is full. Stack is full. In this example, for example, these are the data items. The pop condition, first we have to check for the elements for it is empty or not. If it is empty, it cannot be removed. Now, item in this example, 3 is the first item to be removed. So, here item equals top. This is the top of n minus 1. N minus 1 is the pointer at the last, pointer for the last data item. So, that has to be removed. So, this is the item is copied to the variable item here. Next, if we want to remove this element, please understand the logic here is the top pointer, we have to decrement the pointer from 2 to minus 1, top equal to top minus 1. Means the top pointer from here it comes to this place. Now top equal to top minus 1 means this is the condition. Top earlier it was 2, now it is top is 1, means that the element 3, it has been removed from the stack. Logically, it has been removed from the stack. Now, top is at this position. Top is the pointer at this position. This is the last element. Now, there are 2 elements. Earlier, it was 3 elements. Now, in this example, top is at the position minus at the position 1 or the index 1. There are 2 items. So, this element has been logically removed from the stack. So this is the logic here. So this is the logic and this is an algorithm to remove data item from the stack at the pointer top. Now let us move on to next slide. Here applications of stacks. Now let us see the applications. The simplest application of a stack is to reverse a word. To reverse a word, where we are following this principle. For example, here you take a word A, B, C, D. Suppose this is a word. Suppose if we want to reverse it, so the last we are going to write the last element. Then we are writing C, then B, then A. So this is where this is an application of stack where last element we are writing at the first or at the beginning. So this is an example, one of the applications of stack, reversing a word. Another application is undo operation mechanism in editors. Now all of you are used to computer and you know what is the function of undo. This undo mechanism, it cancels the previous action performed. This is what you have seen in other applications. And conversion of decimal number into binary. See, this is what you have learned last year. Conversion from decimal number to binary. What is the logic here is, suppose I want to convert decimal number 8 to binary, we have to keep dividing the number by 2 and we are going to store the remainder. Here 2 4s are, remainder is this, and again 2 2s are 4, remainder is 0, and here 2 1s are 2, remainder is 0. So at last we used to keep answer like this, means for this 1 0 0 0. See, this is how we store the answer for decimal conversion to binary. So this is as we are keeping the answer from the last index or the last remainder. So this is an example for or it is an application of stack. And another example is to solve tower of an I. It is a game and conversion of infix expression into prefix and postfix expression is another application of stack. Students, in this session, we have discussed about the stack, a linear data structure, and what are the definitions of a stack, how do we represent stack using arrays, and operations on a stack like push operation, pop operations, is empty, peek, and so on. Or we have discussed the algorithm for push and pop operation. And at last, we have discussed the applications of stacks. Thank you very much.